Now let's look at some with negative exponents. So typically when it's a negative exponent, they will only call this a monomial function. That's typically how, let me make sure I spell that right, monomial function. That's typically where we'll separate. They'll refer to a power function typically as being positive, monomial as being negative with one term. That's kind of how you separate for the most part. But I want you to point out some things. One is it's even. Okay, the power is even. Because of that, we know it's going to reflect. Not only that, we know it is positive. Now, the negative exponent, what that does to it is it makes the equation, it's the same thing as moving the power to the denominator. Anytime you have a negative exponent, you can take away the negative by flipping it from either the numerator to the denominator or vice versa. Since it's in the numerator, it's the same thing as this. Now remember, this will have a break at 0 because you're not allowed to divide by 0. So I would have an asymptote when x equals 0 because you're not allowed to divide by 0. Because of that, I know it's even and it's going to be divided on that line. Now, so check out the graph. Here's the picture. You can see how this monomial function got divided now on the y-axis because that's where x equals 0. It got divided right there. And because it was positive, they're up in the first quadrant. Now, we can also learn later that this does have another asymptote going this way, horizontally that is, on the line y equals 0. There's another one there, but that's for a different reason that you don't need to know too much about now. I'll just put it next to it, Bobo for future, and we can talk about that. That's why, or this asymptote comes from, but there they are. This is the one that we can see here by dividing by 0, and since it's even, it reflects. All right, let's try another one. I'm sorry, I didn't do all the domain range and stuff like that. Again, for the sake of time, I'm just going to pause it, see what you can write down, and then unpause the video. All right, here would be the values. The domain, there's a break at 0. Because that infinite asymptote is there, it'll never actually equal that value 0, and that's why there's a break there. You can run it like this in interval notation, or in set builder, it's really easy. If there's only one break, you just say what x cannot equal. X cannot equal 0, as long as x can be any other real number. So that's how you would write that. All right. Secondly, range, we can see it's greater than 0. It does not cross the y-axis. It does not cross the x-axis. As we go to the left, it approaches 0. As we go to the right, it approaches 0. There's that infinite break right there that I was just talking about. And then finally, it's increasing on the left side, so from negative infinity to 0, and it's decreasing on the right side. Next one. Let's try this one. Okay, let's see observations we can make. This is odd. It is positive, though. So the graph is odd. And normally we think of odd being an S-curve, but because this is rational, there's that infinite break that we have. So this one, and it will look like, kind of like the last graph, but instead of reflecting over the y-axis, since it's odd, it'll reflect over the origin. It should go to the third quadrant. Let's see the graph, and here it is. And as you notice, what I was saying is correct. The first side looks the same, but instead of reflecting across the y-axis like the last one did because it was even, this one reflects down because it is odd. We have the same situation occurring. Here, we cannot equal 0 as an x. We have a horizontal asymptote as well there. The same rules apply that I wrote down last time. This is because of Bobo, and you'll learn about what that is here in just a few days. Up here, this is x equals 0 asymptote because x cannot equal 0, or we have problems. So again, let's try the domain range. You can pause the video, and then we'll pick up with the answers. All right, here's the values. We'll see they're almost identical. The domain is exactly the same. It just cannot equal 0. The range this time does go down forever and up forever, but there's a break at 0. There's no intercepts. One more time. As we go left, it approaches 0. As we go right, it approaches 0. There's an infinite discontinuity between the two pieces in the center of the graph, and this time it's decreasing over the whole domain. So there's your values. All right, you try this one.